So first we need to understand what is JUnit. Okay. JUnit is a unit testing framework for the Java programming language. It is written in Java and is open source software maintained by JUnit.org community. What is trying to say is JUnit is also built upon Java only.
Okay.
The main purpose of JUnit is to give us a unit testing framework. Unit testing framework means in our classes we have several methods, right?
Yes.
So you have written some logic. In software companies, what will happen? Single person doesn't maintain the programs for entire lifetime.
Mm-hmm.
I had written some code in Codis, and that is my previous company, and I moved to Pega Systems right now. So what will happen? I have written some codes and I left the company. Someone else has to maintain, right?
Yes. Mm-hmm.
He doesn't know what I have written there.
Okay.
So if they change some logic in any one of the methods within a class, then definitely it will fail, right?
Yes. Mm-hmm.
And they don't know whether the method is doing good or not, whether that method serving its purpose or not, they don't know. If I don't provide any, if I don't associate any test case with that method.
Yes. Mm-hmm.
So as a developer, we will call it as TDD, test driven development. That means
Okay.
first you need to write a test case for the method you are trying to write. So before developing an API, in methods we will call it as APIs also. In hybrid frameworks we will term it as APIs. So before writing a new method or new API, you should write test cases for that.
Okay. Yes.
And
Mm-hmm.
you should associate those test cases with these methods. Then if someone changes logics in your method later, this test case should fail.
Okay. Mm-hmm.
Then he can easily come across, right, the failure, and he can understand that he changed the logic and the test case got failed, so he will revert his logic, or he will try to write a better logic.
Yep. Mm-hmm.
So to write these test cases, JUnit is a framework, is a open source framework which will be used by us. So it
Okay.
is developed in Java only. So you can also write your own framework. No one will force you to use JUnit, but it is a time consuming process, right? Anyway, JUnit
Yes.
is available in the market, and the main purpose of JUnit is it will give us reports only. So you are running 100 test cases. Finally, your
Mm-hmm.
manager will ask you to show the reports.
Yes. Mm-hmm.
He doesn't ask you what is the failure, how many. He doesn't ask you what is the logic you have written in your test case. They don't bother about it. Finally, they will ask you the pass percentage. How many test cases you have passed, how many test cases you ran, and how many test cases are passed, how many test cases are failed. And what is the pass percentage? These four values they will ask.
Yes.
So
Mm-hmm.
these reports will be generated by JUnit. If you write test cases, if you write a test method in JUnit, and if you run them using JUnit, it will give us reports also. It will tell how
Okay.
many failures are there, how many test cases are getting passed, everything it will give.
Okay.
And that is the beauty of JUnit. So it is a unit testing framework for the Java programming language, and it is developed in Java only, and it's a open source maintained by JUnit. So this is all about JUnit. Okay.
Okay.
So what are the important features of the JUnit? So it is a open source framework as we discussed. It provides the annotations to identify the test methods. Okay. See, to do to perform a test, in some cases you need to do some setup, right? So
Yes.
I am testing the logout behavior of Facebook.
Okay.
So to test logout, first I need to log in, right?
Yes.
Login is not my test, it is my setup.
Okay.
After doing some setup only, I can test the test case what I want to test. Okay.
Mm-hmm.
So you should be in a position to separate these test cases from the setup tasks. So in your class you will write several methods. So you should tell right which is a test case, which is a setup task.
Okay.
How the JUnit, how the JVM will know that it is a setup task, it is a test case. They don't know, right?
Mm-hmm.
So to tell them this is the test case, this is the setup task, we can utilize annotations provided by JUnit.
Okay.
Annotations are serving that purpose. Based on the annotations you have given,
Mm-hmm.
they will know that this is a test case, this is a setup tasks. And the okay, after performing the test case, if you want to close the browser, these tear down steps you can place it in one method and you can give some annotations for it, some meaningful annotations. Then it will perform all those tasks after performing the test cases. Like that, there
Okay.
are several uses for these annotations. These are provided by JUnit. Okay.
Mm-hmm.
Provides assertions for testing expected results. Assertions are the ones which will be used to test something, to test the equality, hmm? to compare it with null, to compare the sizes. For that, it will be used.
Okay.
Okay, using assertions, you can compare the things and you can take the decision and you can pass or fail the test case based on that condition. So if you put assert statement, if it is passed, then test case will be passed. If that condition failed, then test case will be failed.
Okay.
Like that it will work. So it provides test runners for running the test cases. So to run the test cases, it will provide test runners. So you are writing test cases, right? After writing test cases, what will you do? You will definitely run it. So to
Okay.
run them, it is providing test runners for us. Okay.
Okay.
And JUnit tests can be run automatically and they check their own results and provide immediate feedback. As we discussed earlier, it will provide a beautiful results for us based on the past and failed test cases. Okay.
Okay.
Yeah. What are JUnit classes? JUnit classes are important classes which are used in writing and testing JUnit. Some of the important classes are asset. In asset class, all the asset methods will be placed in it.
Okay.
Okay, na? Test case means it defines multiple tests within it.
Okay. Mm-hmm.
Text suite means it contains several test classes. Like, uh,
Okay.
yeah, a test class serves a purpose. It contains specific tests. So, to test entire product, we need to club all the test cases together.
Yes.
So, I have 10 test cases, which will test several test scenarios. But to
Okay.
release my product, I need to validate all the test scenarios, right?
Mm-hmm.
So I will club them all together using my test suite. In my
Okay.
test suite, I can place several test classes.
Mm-hmm.
Okay, and the test result will provide us the collection of results of executing test cases. These are the main four classes of the JUnit.
Okay.
Okay. So what are the annotations in JUnit? So I will explain each annotation, each assertion with examples, then you can understand it well. Okay, first we'll see the um, annotations. Yeah. So this is my test class. Okay. So first I will take the test scenario like this. Okay. So I have several methods. If I right click and if I choose run as, it's asking run configuration, but it is not showing the option to run it as a JUnit test case because you didn't use any annotations here.
Okay.
Okay. To recognize any method as a test, you should use the annotation named test. Sorry. Before writing JUnit test cases, you should add JUnit jar to your project because JUnit doesn't come along with our Java. It is a third party jar. Okay. So I am adding a JUnit jar. So at the rate test. Okay, I added these annotations which comes from org JUnit test. If I right click on, so see this option is enabled now. JUnit test. It will come only when you have at least one test method in your class. How can you make an ordinary method into test method? By adding the annotation at the rate test. Okay.
Okay.
JUnit test. I ran it. I have three methods, but it ran only one because it will consider only test methods. A method can become a test method only if you add this annotation prior to that method. Okay.
Okay.
Okay, this is the purpose of test. If you add testing annotation in front of your method, then it will become a test method and it can be considered in your test cycle of the JUnit. Okay.
Okay.
And one more annotation we will learn. So my manager gave me task like this. So I am validating Facebook. He said, so he asked me to validate Facebook. So to validate functionality, to validate features of the Facebook, first I need to log in, right?
Yes.
After my testing, I need to log out. So the there would be two use cases. One would be you need to log in and log out for each test case,
Okay.
or you will log in, you will perform all your test cases, then you will log out. That is one more scenario. So there would be two test scenarios. Okay. So first my manager asked me to log in and log out for each and every test case.
Okay.
So in that scenario, so these are not, these login and logout are not my tests. These are my setup tasks. My test cases are different, but login and logout are my setup and tear down tasks. Okay, you got it.
Okay.
So in case of that, I will write login in one method, I will write logout in another method, and I will use an annotation named before, and I will use annotation named after. So what will happen before and it can be explained well if I have more than one test method. Okay. So if I run this method, see, implementation of login called twice.
Okay.
Logout is also called twice.
Right.
So if you use before, it will be called for each and every test method you have in your class.
Okay.
If you use after, it will be called after the execution of each and every test method in your class. So before is called first, so implementation of login is printed here, then test is called, so testing is printed here, then after is called, it didn't call test2. So for each and every test case, before method will be called, after method will be called. Then for test2 also, before method called, that's the implementation of login is printed here. Then testing2 is called and logout is called. Okay. So if you want to do something for each and every test case prior to it, then put it in a before. Put it in a method and use at the rate before annotation. Before annotation will be called before execution of each and every test method in your class. Okay. If you want to do something after execution of each and every test method, then put it in a method and associate at the rate after annotation to it.
Okay.
It will be called after the execution of each and every test method in your class. Okay.
Okay.
So my manager asked me to log in and log out for each test case. So I used at the rate before and at the rate after.
Okay.
But now the test scenario is different. On the next day, he asked me to change the test scenario like this. Just log in once, do all the test cases and log out.
Okay.
He asked me to log in only once. He asked me to change the test scenario. Then I will do like this. At the rate before class.
Okay.
At the rate after class. So the error is due to the method login should be static. If you use class, the method should be static. Okay. Because as I explained earlier, class level things will be stored in static blocks, right? So you should make it as static. See, implementation of login is called, testing is called, then testing2 is called. It didn't call implementation of login again, it didn't call logout again, because if you use before class, it will be called only once.
Yes.
Before executing any one of the test methods in your class, it will call before class, then it will execute all the test methods. If you have 10 test methods also, it will be called only once. Irrespective of the test methods in your class, it will be called once before all the test methods are going to be executed. Then after executing all the test methods, then after class will be called. Okay. Unlike before and after, it didn't call this method for each and every test method. It will be called only per class, not per test case. Okay.
Okay.
So
So
you
I
got
have
it
a
right.
doubt too. Yeah, at the rate of before అని యూజ్ చేశారు, at the rate of before కి at the rate of before class కి డిఫరెన్స్ ఏంటి?
In case of at the rate before, you are calling it for each and every test method.
Okay. At the rate of before class కి we are calling it only once.
Only once for the class. We'll see it.
Okay.
If you have two more test method, one minute. రఘు కొంచెం సౌండ్ తగ్గా. So I am adding two more methods. This is testing 4. I am running it. So this is my output if I use before class and after class. Now I am running the same class by changing before class and after class to at the rate before and at the rate after.
Okay.
Now this is the output. See, this is test 1. Before that, implementation of login is called, logout is called. This is test 2. Implementation of login and logout is called. Implementation of login, logout. Implementation of login, implementation of logout. So for each test method, before will be called, after will be called. But in case of before class and after class, it will be called before execution of all the test methods.
Yeah, okay.
After class will be called after the execution of all the test methods, irrespective of the number of test methods.
Yeah.
Okay, you got it right?
Yeah, I got it.
And one more thing you should observe here. I placed test 2 as the second test method.
Yes.
But testing 4 is printed here. So
Yeah.
JUnit doesn't guarantee you the order of execution of test methods. If you place test methods in an order, doesn't mean that it will run in the same order.
Oh, okay, okay.
It will pick up in the random way, like hash set, hash map we discussed, right?
Yes, yes.
It doesn't follow the order. Like that in JUnit also there is no guarantee for the order of execution of the test methods.
Okay, okay.
So don't make any dependencies in between the test methods. Someone will write the test cases like this. In test 1, he will write some code. Depending on that code, he will write something in test 2. That is wrong. You should not build dependencies in between the test cases. Test cases should be independent.
Oh,
If you want to do some setup tasks, then do it either in before class or before.
okay.
Don't do it in the prior test method, because JUnit doesn't guarantee the execution of the order of execution of the test methods. So if you put dependencies, definitely it might fail. Okay, remember that also.
Okay, so is there any way can we sort the order or that kind of stuff?
Yeah, we can do that, but not using JUnit.
Okay.
Actually, there is a third-party jar called ASM jar. See, and this problem came into picture after Java 1.7.
Okay.
Till Java 1.6, it used to execute the test method in the same order they have written. But in Java 1.7, it is picking up the random order. So we faced this issue also, because in Java till Java 1.6 it is executing in the same order, right?
Yes.
So in my company also they have written test cases in that. They build dependencies in between the test cases. They have written some test case based on the first test case. They have written second test case. So
Yeah.
if we migrate our systems to Java 1.6 to 1.7, they are starting fail. So we worked on it for 1.5 day. After that, we realized that it's picking up the random order.
Oh, okay.
So we had taken help from ASM jar. There is a jar named ASM jar.
Okay.
So we downloaded that jar. In that, you what will it do is it will get the method numbers for each method. So this
Okay.
is login, right, method. For this, line number is 10. For test, what is the line number? 16. For test 2, line number is 22. So if you sort your tests based on the line number, definitely they will be in order, right?
Yes.
So we used that jar. We got all the test method names. We got all the numbers, line numbers associated with it. So we sorted this test method using these line numbers.
Okay.
And we have written some custom code for that. So that is the way. If you want to run them in an order, there is a way, but not you can't do it using pure Java. You need to add that ASM jar, and after taking help from it, you can do.
Okay.
So this is all about JUnit annotations, and one more annotation is there. That is ignore. So I have around 10 test cases. For every release, I am running them.
Okay.
But one particular release, the test case is not needed.
Okay.
Like that is a known issue to me. I have already known that that issue is there, and I decided that I can ignore it for this cycle, test cycle.
Okay.
So if I want to ignore a test case from test cycle execution, then I will use this annotation at the rate ignore. Okay.
Okay.
If I use this ignore, then it doesn't consider it in run cycle. See, testing is there, test 4 is there, test 3 is there. It didn't run test 2 because it is ignored because of this ignore annotation. Okay. So if you want to ignore a test case from the test cycle, then you will use ignore annotation.
Okay.
Okay, totally how many annotations will end? 6 annotation. What is the purpose of test?
Okay, at the rate of test we
Yeah.
are talking about. Okay, it provides the test run to test. I mean to run the test.
Yeah. To consider a method as test, you need to associate that method with test. If you use test annotation at the rate test annotation, JUnit will consider it as a test method. Okay. See, and these results will be generated using JUnit itself. See, it is telling us, right? Test is passed, test 4 is passed, test 3 is passed. Like that, it will tell us,
Okay.
and it will give us the execution time also.
Okay.
Like this, and this test 2 is ignored, right? That's why displaying like that, like this.
Okay.
Okay. And then first annotation is test will end. Then to ignore the test case, which annotation you will use to ignore? You will use at the rate ignore. Okay. Then if you want to run some test setup for each and every method, which annotation you will use?
At the rate of the before.
At the rate before you will use, because
Yes,
it has
okay.
to be run for each and every test method. But if it has to be run for only once per the cycle, only once per the class, then you will go ahead with at the rate before
Rate of
class.
before class. Okay.
Yeah. If you want to perform some tear down operation for each and every test method, you will go ahead with at the rate after.
After.
If you run it only once, then
At the
you will
rate
use
of
at
the
the rate
class.
after class. Okay.
Mm-hmm.
Yeah. So go through this. At the rate test. This test annotation tells JUnit that public void method to which it is attached can be run as a test case. At the rate before. Several tests need similar objects created before they can run. Annotating a public void method with before causes the method to be run before each test method. At the
Okay.
rate after. If you allocate external resources in a before method, you need to release them after test runs. Annotating a before public void method with after class the method to be run after test method. So what he's saying is allocate external resources, like if you make some file connections, database connections, you
Mm-hmm.
should close the connection, right?
Yes.
So if you are using yesterday we have written codes to read Excel files, write Excel files, right?
Yes.
So
Mm-hmm.
to read the Excel file, what will you do? You are giving some file location. That means you are making connection with that file. So after you reading that Excel file, you need to disconnect it, right? You connected to that file. After your operations, you should disconnect. You should
Yes.
release that connection. So that codes you will write in after class, after method. He's saying after using after annotations, you can call all that code after the execution of your test methods. Okay. Before class, annotating a public. See here, just he said public void method, but in case of before class, you should make it as public static void method.
Void.
And one more thing, the return type should be always void. You should not make it as int or string, then it will definitely fail.
Okay.
Okay, na test method should not return any values.
Okay.
It is giving error, right?
Yes.
Okay, not like this. See, method test2 should be void. Okay,
Mm-hmm.
so you should not keep any other return types. You should not keep return types actually. If you make it as void means there is no return type. Okay,
Okay.
in JUnit you should not place any return types. So in case of at the rate before class, you should make it as public static void method. In case of after class, also you should make it as public static void method. It is used for cleanup activities. Ignore annotation is used to ignore the test case. That is, the test case will not be executed. Okay. So these are the annotations. Now we will look at assertions. So why do we need assertions? So to understand this, I will place few classes com.11.utils. So in that I will place few of my programs. Java, com, Java. So anagram. So have you heard about anagram?
No. No.
It is paste. Yeah. So I placed several methods here, several classes, sorry. So first I will write this test case. I will write this I will run this program. Oh, have you heard anagram? You know what does it mean, anagram?
No.
Anagram means permutations of printing permutations of a string. So Swati means how many letters are there? 6 letters are there and all are distinct. So 720 combinations we can print. Okay.
Okay.
These are the combinations. These are the permutations we can make with your name.
Okay.
Okay. So my manager asked me to write test cases for all these utilities. He asked me to write test methods to validate the APIs within the util classes. Okay.
Okay.
So this is my string. This is one of the anagram, right?
Yeah. Mhm.
No, not anagram because it's not returning anything, right? So we can't write proper test case with it. We'll ignore this for now. So we'll take one of them. So string reverse. It is returning string. So if you want to validate a test method, that should return something because we will compare this return value with the expected value. You can't write a test method for the methods which don't have the return types because it's not returning anything means you can't compare the value, right?
Yes. Mhm.
That's why I skipped this do anagram. It contains return type as void, so we can't write test method for it. So I have
Okay.
taken this string reverse. So string s equal to Swati. So if I return this, if I reverse the string, what is the output? What is the expected output? expected output equal to I H T A W S. Okay, I will write my expected output here.
Okay.
Now I will assert dot assert dot assert equals expected output I'm creating object for it. Reverse object dot now we will make this obj object obj dot reverse Swati. Where did it test? So in this test case I am validating the behavior of reverse method of string reverse class. See, it is passed because the expected output and the actual output are the same. So this reverse method will return something, right? So if I give this name Swati, this is the expected result.
Okay.
So both should be the same. So the test case is passed means the logic is right within the method. See what will happen if I write some wrong logic here. Okay. Someone changed it like this. Instead of putting len, I wrote it in, I wrote correct implementation for this method. Okay. After some time, someone changed. They don't know that if they change the logic here, it will fail. So they changed it. After that, if they run the test case, definitely it will fail. Stack overflow. Some error came, right? Like that. These test cases will be helpful for us to validate the methods in our class. So, and one more thing, like he is returning, right? Return reverse. So someone changed the implementation again. If they run the test case, it will fail because instead of returning the return type, instead of returning the reverse value, every time I am adding a here, right? So because of this, this is the expected value I have given here, IHTAWS, but the actual value is, because I added a here, right? The actual value came as like this, IHTAWS, a is added, right? So it is failed. It is saying comparison failure. Expected is this one, but actual one is this.
Okay.
So using the assertions like this, we can validate our test. We can validate methods in our classes.
Okay.
And that is the way. Assert dot equals means. So if I write correct implementation, then only it will be passed. So this is the right implementation. If I run the test case, it is passed. Okay.
Okay.
So this test method will be associated with that API of the string reverse class for the lifetime. So if the test method is passed means then only the implementation is right within that method. Like that we can consider. So before writing any method in our classes, we should write test cases like this, which will validate the functionality of the method. So max and min number. So this is my array. So which is the max number in this? 9, right? That is my expected now.
Yes.
Find max. Two are passed. Test max is passed, test reverse is passed. Okay. So I went here and I am changing the implementation. So I changed it as less than, right, instead of greater than. So it's returning min value instead of max value. If I make it as greater than, it will return max value of the array. If I make it as less than, it will return min value of the array. So unknowingly someone changed the implementation. So this test case failed, right? After seeing that, then he will change the implementation again. See, expected is 9, but the actual value is 1. So he realized he will definitely realize his mistake after seeing the result, test result. Then he will do the corresponding changes to the methods. Then if we run it again, then it will be passed. Okay. So using this JUnit framework, we can validate each and every method in our classes. This is the unit testing framework which will be used to validate the methods and classes in our product. This is called backend validation. Okay, we are not touching any user interfaces, right? Any browser is not coming into the picture. We are directly validating the APIs within our class. Okay.
Okay.
So in assert there are several types, not only assert equals. So if you want to compare equality of two objects, then you will go ahead with assert equals. See, assert array equals is there. Using assert array equals, you can compare two byte arrays, you can compare two char arrays, you can compare two int arrays. Okay. So based on your need, you will use one of the asset method. So you can use asset equals to asset different objects equality, like you can asset to strings, you can asset to object arrays, you can asset to objects, like that you can do. Okay.
Okay.
And if you want to check either a condition, then you will go ahead with asset false. Asset false will pass the test case only the condition is getting failed.
Okay.
We'll see that also. So we use asset equals at the rate test. Fibonacci also we can test. Prime number. Number is also not really count. Armstrong. Allow not returning anything. Okay, we'll look at it like this. So I changed the implementation like this. So what this is Armstrong method will do is, if the number is Armstrong number, then it will return true, otherwise it will return false. Okay. Do you know what does it mean by Armstrong number?
No.
Armstrong means 153 is an Armstrong number, because 1 cube plus 5 cube plus 3 cube is equal to 153 only. 1 plus 125 plus 127. So total is 153, right? So we have a number and sum of all the cubes is equal to that number, that is called Armstrong number. Okay.
Okay.
So if you want to check this test, asset dot asset false, So 152 is not an Armstrong, right?
Yes.
So it should return false. So I am asserting it as false.
Okay.
It is passed. Okay.
Ah,
So if I make it a, if I run the test for 153, it should fail because see assert error, because we expected that it will return false, but it returned true because 153 is Armstrong number, right?
yes.
So you can validate it as like this, like assert false, assert true is there.
Okay.
Run as, so it is passed. So like that we can use assert true and assert false. If you are validating a true condition, then use assert true. If you are validating a false condition, then use assert false. Okay, like that many asserts are there, but basically we will use mainly these things: assert equal, assert false, assert true, assert null also. If you want to assert a
Okay.
null value, then you will assert it as assert, you will use assert null. Okay, so assert equals, assert true, assert false, assert not null. So if you are asserting whether the thing is whether an object is not null, then you will go ahead with assert not null. Okay,
Okay.
if you are asserting a null value, you will use assert null, or assert same. You will use whether two objects point to same object, assert not same, and assert array equals. These are the things. So, and one more important thing is, what is the difference between assert equals and assert is same? Assert equals will compare the contents within the objects. Assert same will compare whether both are referring to the same object location. We didn't discuss about constant pools, I guess, so it's not the right time to discuss about it. But the thing here is, this is object, this is object. Okay, some content is there. Here C is there, here S is there.
Mhm.
Its memory location is 120, its memory location is 150. Assume like this. Assert same will compare these two. It will compare 120 with 150,
Okay.
because it will compare the addresses. Both the objects are referred to the same thing or not, it will compare.
Okay.
Whereas assert equals will compare these two. It will compare the contents. Assert same will compare the addresses. Okay.
Okay.
So remember this. This is the difference between assert same and assert equals. Okay, these are the assert statements, Swati. So we covered what does it mean by JUnit. We covered JUnit annotations. We covered JUnit assertions. So I will explain test results tomorrow.
Okay.
It will take I think just 10 to 15 minutes.
Mhm.
So from tomorrow onwards we'll continue with Selenium.
Yes, sure.
Okay, do you have any doubts in today's class?
యాక్చువల్గా శ్రీనివాస్ నాకు రోజు రికార్డింగ్ పంపించట్లేదు